So yes, I'm Scott Simmons. I'm the Chief Standards Officer over at the Open Geospatial Consortium, the OGC. And today I want to frame the conversation of integrity, provenance, and trust around AI so that we sort of have a common background of the problem set we might be looking at and some of the solutions that are already underway. And in my title today, really, we must have trust in our data to have trust in our AI. And oh yeah, by the way, we do need to understand the models and the people involved in this work. So there's a lot of moving pieces that I want to walk us through today. So first, really quick, if you don't know about Open Geospatial Consortium, OGC, we're an organization dedicated to ensuring that location data, geospatial data are interoperable, that you can use that information in context, be it in the spatial need purposes or for other purposes. And so we do that through standards, through research, through development of practices, and convening and speaking at events like this. We are nicely balanced in membership amongst commercial, government, and research and academia. So we have really fully engaged participation from all sectors of the geospatial and adjacent communities. And that's really important when we talk about this concept of integrity, provenance, and trust, because we need to understand that there are multiple perspectives of how the data will be used and people outside our little specialized community that have done some really clever work here. So let's frame the problem first. Let's talk about it from an AI perspective. I've seen no shortage of news articles recently about spoofed spatial information, be it satellite imagery that's been altered in various war zones to convey a story. Come on, we've been doing this since photographs were taken from balloons a long time ago. People could fake information or do double exposures, etc. But you know, it gets serious when something like the Spanish government is publishing on their national websites a sort of guidebook on how to ensure the authenticity of your imagery so that you as a user can understand what might have happened to the imagery and what you can do to ensure that it is authentic. You're going to hear a little bit from Denise about a really great source of this kind of information, of overhead imagery data that itself is very highly curated. But there's a lot behind what might happen between that data being collected and getting to you. In short, with AI, right, we can do anything we want. We take our satellite image, we run it through this black box of AI, and at the bottom, you can get a really cool analysis that some of our friends at National University of Singapore did to look at the livability of the island of Singapore. Or you can create a prompt like I did on the top, take that same picture and get a child's map of Singapore that kind of looks a little bit like it, and it looks like a child's map, and so everything works out okay. That's the same data, different prompts in the algorithm. So the complexity of what we might be able to do with AI and all the problems in there, not just from our prompt engineering, but on our source data and our validation are pretty significant. So let's sort of step through these. How do we work through this problem? What can we control in our community? And I'm bringing this from my perspective in the standards community. What are those things that we can develop rules and guidances around that ensure repeatability of your work in AI? And so on the left, we have the variety of sources of information, be it our imagery, our training data, some ancillary databases, graph knowledge, etc. We run it through that AI box and we get something out the other end. So let's step through these things that we can control, starting with our source imagery. Right, we have some, and there are certainly other AI methods and means, but we're going to use source imagery today. We have information that needs to be highly correlated. That means if a sensor is picking up a variety of different frequencies, bandwidths of information, we need to ensure that we understand what those are and how those all align. And so you look at some NOAA, NASA weather satellite imagery over the contiguous United States and understand these variety of sources of information and how you might put those together. You need to know where they came from, how they align, etc. We also need to fully understand the heritage of our information. Here's some Landsat data over the place where I live right now. And not only can I get the information itself and understand the footprint of the data and sort of a preview of what it looks like, but most important to us in this spatial world, metadata. We're great at metadata. That's one thing all the other data communities I work with are jealous of, that we spatial people are complete metadata nerds and we go crazy on metadata. That's really important information. You need quality metadata to go through with your data that you're bringing into your analytics. We also need to be able to control how we train our models. So the training data is linked to the results we want to have, and we need to be able to make sure that that training data is the right data for our analytics, and that the training data do what they describe they'll do. And so OGC has published over the last couple of years a 3-part standard on training data markup language for artificial intelligence. I know that's a mouthful, but it says what it is. How do you describe your training data to indicate where it came from, what it's being used for, and was it successful in that use? It can also be your verification information. And so it's a really simple standard, just looks at what your training data set is encapsulated by, the quality of information, how it's been labeled, what AI tasks it's been applied against, has it been changed, etc. This little bit of information, provided it stays along with your data, ensures that your training data is reusable in the appropriate context for what you want your results to be. And so standardizing the way we describe training data takes one variable out of our equation of understanding how our information is going to be processed in an AI context. And there's been a lot of work now done, particularly led out of Wuhan University, on adding these training data information to a variety of source data sets, and then running them through any number of AI tools, be those more commercial tools or their own proprietary tools, even running them through our traditional large language models. So it's a nice standard, simple, and encoding in XML or JSON, so it makes it easy for all of you to consume. Now we have other information we're going to use. We maybe have our satellite imagery, but we need some context. We have related data. We might have feature information, vector data that describes what rivers are flowing and which ones are dry. And so we need to be able to understand not just the metadata around those data and what they do, but how they fit in the context of the larger analytic framework. And so there was a research project OGC completed last year on climate intelligence work, trying to bring a variety of source information, be it somewhat dynamic imagery data and more static long-term information that was more easily described in databases, and fuse that information into an analytic framework run by AI to look at real-time prediction of climate impact to a variety of, be they weather scenarios, climate scenarios, et cetera. But what are we going to do to our planet's surface as a result of these events? And so it's that fusion of information, but we must understand each of these pieces. And I'm going to come back to a bit more about where we're leading to that in a moment. Also of critical importance is the relationship of all these types of data. This is perhaps, in my mind, the most important thing we can be doing right now, and that is standardizing or coming up with well-vetted, well-known knowledge graphs that describe how spatial information is used in our context. There's an OGC member, TerraFrame, that's been doing some really clever work with developing spatial knowledge graphs to help guide a large language model in making its inferences based on the information at hand. And so you can use those graphs in the training of your model, but also as you're running your model, those graphs can be part of your prompt, your information going into the model. So they're quite useful in both contexts. A great example that they've shown here is the concept of a river and a levee. So we all know that a levee sits on either side of a river to prevent floodwaters from leaving the river and flooding adjacent land, be that farmland, cities, whatever. And they're close to each other. The levee sits relatively close to the river. But that context of the protective aspect of a levee is very, very important. It has a very specific relationship with the river. And we need to have a graph that describes, no, they're not just adjacent to each other, and one of them's a low spot and one of them's a bit of a high spot, but one of them is actually designed to help protect certain occurrences from the other. And so that knowledge graph, that ability to tie information together is really, really important. And I will make the bold statement that I really believe in the coming years in our work in OGC, we're going to be spending more and more time trying to curate, develop, and characterize knowledge graphs than we will be writing these fundamental standards. We kind of got a lot of that standardized stuff figured out now. What we really need is to provide our community really high quality knowledge that helps that community interpret its data in the context we're all used to or brand new contexts. Finally, with our output data, there are some things we can control here. In particular, we want to understand the quality measures. Did you really get what you wanted when you went out and running to fetch that stick? Did you really get what you wanted when you ran your AI analytics? So OGC and ISO have been working together to develop a quality measures registry. That is an online repository of, again, highly curated quality measurements, mathematical measurements of quality or other aspects of quality, quantitative or qualitative, that can be registered such that anyone looking at information that has quality information assigned to it, quality data assigned to it, can go back to an authoritative dictionary and understand exactly what that measure meant. And think of that when you're looking at your analytical results on all of your input data. What is the spectral characteristics of your satellite imagery that you're starting with? And at your output, did you get realistic interpretations based on that input spectrum? Did you see something that should be interpretable based on your input? And understanding the measures by which you determine, did you get what you wanted? That's really, really critical to have an authoritative source of these measures so that you don't have misleading information characterizing data in a fashion that's a statement, not truth, but also so that you can really compare sort of in an apples to apples fashion your analytical results. I have said that my output results have a certain horizontal accuracy based on the input data. And if you have those quality measures in your input data and you've characterized them correctly in the output, people can go back and validate, did you really deliver what you promised? And so we see that as one of those things we can control. And finally, that black box. Is there anything we really can control? I mean, AI really is, there's a variety of algorithms. They're going to continue to grow. There's going to be more and more at the time. What can we control there? Well, there's one thing we can do, and that is describe what the algorithms do. Describe what type of information they take as input, a general characterization of how the algorithm might work, not talking about the details, no math, no secret intellectual property being shared here, but metadata around the model. And then finally, examples of where the model's been successful. And so collecting that list of examples. And some more work also from our friends at Wuhan University here on should you describe your models really well, you can actually automate a system that checks and finds of my model library that I have, which is the one most well suited to the analytical problem I want to solve. And so having this metadata about the model is really important. And while there are many, many standardized efforts around the world on how you might describe AI models, there are certain characteristics of the spatial information we like to work with that mean we want to have a little bit of our own characterization as well. And so leverage what others are doing and do some of this work ourselves. So we have a proposed deep learning model standards working group about to start. There is a charter available for the public to review. So I've got a link in here and I can post it in the chat later. Do take a look at that and tell us what you think. Are we describing this model properly? Do we have a plan in place that you think would be suitable? All right, so ultimately now we want to arrive at this framework for integrity, provenance, and trust. I just laid out a problem. I laid out some of the things we can do to control it. So how are we going to respond? We need to be able to characterize the integrity of the data, how it's been handled, its origin, what various degrees of completeness it might have. We need to talk about the provenance, just not where it came from, but how has it been touched and modified through time. And finally, once we understand these two characteristics, the integrity and provenance, we start to develop metrics on trustability of the data. Is it suitable for my purpose? Is it trustworthy? And so how are we going to do this kind of work? Well, we want to work with our existing standards and good practices, not just generated in OGC, but in a lot of other organizations, such as the Creator Assertions Working Group and others who are looking at ways to describe and characterize integrity and provenance in a consistent fashion. We want to work with that common language for quality I described. Ensure that we have standardized formats. Our processing should be characterized in an immutable record. So it'd be a blockchain or whatever else you might use for all those processing steps. And then finally, share those user experiences so we can start building that framework. How are we doing that? Well, it's the way we operate in OGC. We do all of our standards and practice development in an infinity loop here. So just like Alex told you that these Geo Awesome events have infinite fun, we've got infinite research going on. We experiment on this kind of work in the context. We try to do real world experimentation against the problem set, and we feed that into a standardization cycle to try to set down the rules for those things that we can control, characterize, and have community agreement on need to be standardized, right? And we work those through that cycle and then feed them right back into a research environment again and continue to experiment against now standardized solutions and see if those were suitable. And if they're not, well, we got to go back to the loop and work these over again. But this is really how we operate in OGC and what's really important for us to develop our standards. So we just finished a test bed 20, literally the reports are being published now. You'll see in the lower left, our task 1 from this test bed dealt with integrity, provenance, and trust. We were doing a lot of research on how to characterize these efforts. Now, test bed 21 literally started last week. If you want to get involved, contact me. You can become an observer and watch what's happening. And look, right again, we have another integrity, provenance, and trust task in here. And now we're starting to go deeper, not just characterizing what we need to understand, but how we're going to share information about integrity, provenance, and trust. And finally, coming up in just a couple of weeks, OGC will be holding its 133rd member meeting in Boulder, Colorado. And on the 30th of October, we're going to have a session to talk about provenance standardization. How are we going to characterize provenance? What are we going to use in the community? What might we develop ourselves? So that's going to be at 1500 Mountain, 2100 UTC. If you are interested in attending, again, I'll leave my contact information and let me know. This is a session open to anyone in attendance. So with that, I want to thank you for your time. And thanks again for the organizers, and I look forward to seeing some fun questions.